Hey team, how are we going? I hope that you'll be able to bear with me as I recover from my cold. Hopefully, my voice will stick together. What we are doing today is looking at how strings are represented and how to create a type that looks like a string, even though it has different semantics. This is inspired, or heavily inspired actually, from the small underscore stir type, um, which actually provides the ability for you to keep your string data on the stack if it's very small. Otherwise, it dispatches out to the heap. And we want to do something that's relatively similar. But I thought that an interesting thing to do would be to say we'll have our sort of data in here, and we'll say that our data is some sort of other struct. So this one here is public. And we've got an internal struct, which is where our data is represented, or sort of an internal representation. And inside data, its job is to hold some buffer. And we will use just a vector of U8 for now. Which is, and when the data comes in, it compresses what's there. And when it's trying to be seen as what I'm trying to show you is that when the data comes into our type, we compress it, and then when it's treated as a string, it is automatically decompressed on the fly. So you might have some sort of long text that is sitting in memory, and you actually are not too worried about the CPU cost of interacting with it, but you think that it would be useful to have it small in size. Hopefully this will be somewhat interesting to you. If not, feel free to close the browser or find something else to do. I am very enthusiastic about the idea of you exploring on your own. Feel free to either check out my other videos or something that might be more interesting. If you're here live, which we have, just a note from Ollie. Please do say hello. That's wonderful to hear from you. If you are not, please hit subscribe. The best way to get notified of new events is to actually subscribe to the channel or follow me online. That way you can be part of it. And yeah, so let's look at how small string does it, and then we can kind of riff off that to try and find how we might want to do it. And what we'll find is that they use this pattern. Small string uses a slightly different convention. They start with their internal one is called repr for representation, but we're just going to use data because we are fun like that. I just wanted to make a small change, which is to make sure that everything stays in dark mode. Otherwise, it's going to be kind of irritating as your eyes try and flip between light and dark. So just one moment. Change that on my computer. You'll probably see me. Oh no, I'm able to do it without revealing my secrets. So I've got here a small string. So how do we find the internals of this thing? First, what I like to do is go to crates.io, and then we get the repository. So it's actually tucked into Rust Analyzer. Rust Analyzer uses this. There's essentially a compiler, and its job is to parse many strings, and it wants to use this in a very compact way. It also needs to be very broadly usable. And so the small strings crate actually prohibits the use of the standard library. How about, and it has a bunch of other things. So it pulls a bunch of standard, I say standard library types. It's actually from the alloc crate inside the standard library. So a subset of the standard library called alloc. as well as a subset of the standard library called core. We will actually, I'll move that to the side. That's more of an advanced technique just for you to be aware of. We're actually not going to worry so much about restricting ourselves to no standard library. We won't need the standard library in practice. But if you're not familiar with no stud, it can be useful to just avoid it for now. So what we're interested in is actually recreating something that looks very similar. I've got small string here with a repr, and then the thing is that a small string always pretends to be a string. And so what you see at the bottom are a large number of trait implementations. So for example, if you're comparing a small string against a reference to some other string, or in fact, here's partial equality for string. So you have many other things that are, you have all of these traits defined, and the definition of all of these traits allow the interoperability to work. And what we are going to do is, if I hunt for it, is the as_stir method is what we are going to rely on to essentially masquerade as a string, even though we want to compact our data as it comes in. Okay, so first of all, we need some sort of compression algorithm, and I'm going to cheat a little bit and say that let's start by not compressing the data and just creating some other type that is able to pretend like it's a string. Hopefully that will make some sense. So I've got some method here. I'll just check the comments as well. So I've got no comments so far. That's, let's say, good. Presumably that means that there are no questions. If there are questions, let me know. So we're going to create a new method which will take in, let's say, a string slice and return self. Then, let's just call this text. And here we have a cursed string, which contains a data, and inside data is a buffer. And buffer is a variable, which is a vector of U8, which I can recreate from a string slice by asking for, I can either do it one of two ways. I can ask for individual bytes and then collect, which will go and essentially, it might be smart enough to avoid duplicating. So this is an iterator that returns the individual bytes, and then we collect into a vector. The type inference will actually say, aha, you're trying to use this as a vector. Now so I don't need to actually define the collection type. Whereas often you'll find the use of the collect method will require a type parameter. That's not necessary when the type hints can do the work for us. Okay, so cursed string data, right. We need another one, which is as string. And I want to just check, I'll do this off the side, whether or not as string is part of a type, part of a trait, or if it's just, yeah, okay, cool. What we're going to do is present ourselves. We want to provide a method which can take us out a reference to self and return a string slice, which will be essentially we need to promise that that this vector of U8 is actually a string. Now, we might get tied up into issues with the borrow checker at this point. Whenever you have a function that both accepts a reference and returns a reference, Rust is going to maybe try and force you to choose. And so let's see. Actually, what I want to do let's try this. So the first thing here is to go self 0, so the data, and then I want to call, so it's a vector of U8, and then, so if I had, let's just actually extract it. And it can take a buffer, which is data. This syntax may look a bit odd, but essentially we can use let to actually do a rich pattern match. So I'm actually assigning a variable to the internal field of data automatically. So now I've got a variable named data that I don't need to kind of manually go and call methods on to unpack. Now we need to iterate and convert everything. We need to say that we promise that this data is actually a string. And the method that we're going to call here is from UF8 unchecked, and it asks v for value in the let's see if I can widen this out. No, unfortunately not. So the v up the top here takes a byte slice, and v stands for value, and this buffer is our value. So if I take a reference to that, or I borrow, I'm probably going to have issues with the borrow checker. Actually, we'll just do it with without the unchecked, because that's going to change things. So I want to focus at the moment on, and I know this will always succeed, so I can unwrap. Self.0 is getting a bit angry with me. I should probably borrow there. Okay, fine. No, I don't need, and I'm going to get the linter telling me off. It's going to say, look, you can shorten this. So that's fine, that's easy. And here it says, you don't need to do that. You've actually borrowed on the actual field itself, and now you no longer need to borrow directly. So here are two options. We know that we can guarantee that we didn't touch the data, and it was originally a string. We have essentially performed no transformation on it. So we can guarantee on the other side that it will stay. We uphold this invariant that UTF-8 has been retained, even though we sort of erase the type because we convert it to a raw vector of bytes, and then we bring it back. Okay, so how do we go from here? One of our other options, instead of using unwrap, which incurs a tiny, fractionally small piece of time, is we can actually wrap this thing in unsafe and use the unchecked method. Source. Okay, so the source data was UTF-8, hasn't been touched, therefore it is guaranteed to succeed. Super. Now, we have, let's test it. So, we can do this in a test module, but for now we're kind of for winging it. It's like a round trip. And I'll mark this function as a test. So the round trip function takes some string, and let's call it a... Oh, you know what I should do? I should plug my website. This is the conventional thing to do when you are a content creator or an influencer, is to start advertising yourself. So here we go. https://timclicks.dev. There are a bunch of other videos that you might like to explore, and there's going to be more coming. So we have some sort of string slice. Here's our data. And right now we want to be able to show, so cursed is cursed string new. Although I suppose this should actually be from. Okay. Sorry. To do change this to from. I should not get distracted. So we've got some string slice. Here's my data. And then actually I'm going to do something cheeky, which is clone it for a reason which will become obvious slightly later. And now I want let data 2 is cursed as a string. So what I've got is a copy, and what we're going to check is assert that data and data 2 are the same. It's saying it's actually not really necessary, but I actually would like it to be this. Oh, you know why it's not necessary? It's because this bytes collect call actually does create a clone itself. So there's no point in me creating sort of a superfluous call. I think we could do better by essentially, but whatever. Okay, so we run the test. We get an okay. Hey, wonderful. Go us. We got we're able to get our test working first go. We haven't done a lot of work yet, but this is showing that essentially we can essentially erase our type and recreate it. And now we have a fragment of what we're going to do next. So how about one of the annoying things is calling this as a stir method. And so why don't I try to teach Rust that the cursed string is actually just like a string. And so one of the ways that we need to do this is through the Deref trait. And this is kind of one of the cores. So we've got this as string method, which eventually will be our decompression step. One more thing. I'll ignore it for now. I just wanted to change my... Okay, so the next step is to implement Deref. So the Deref trait is interesting. It's kind of one of the parts of Rust that introduces, let's say, magical control flow. It enables one type to pretend that it is another. So I will be able to call all the methods of a string on cursed string by implementing this thing. So we're going to say that the associated type for Deref is a string, and str with no ampersand means just some span of bytes which is guaranteed to be UTF-8, and there's no special so what we're saying is that my cursed string dereferences to a string that you know and love in the standard library. Oh, that was a strange expansion by my editor. So we take a reference to self, not slef, and return. We can do it this way. So I could do we can actually say that it's like self target, or to simplify things, and in fact it's a reference to self target. So that will link the associated type with this, but it can be just easier to do this. So now all I need to do is self as string. The method can stay private. So this is like an implementation detail for me, but oh, I've got a warning. I need to import this. I can do it in one of two ways. I can, I'll just import the thing at the top. So it's from the extent, and hopefully, so this is the round trip. Sort of the manual way, and I'm going to do round trip via Deref. So ideally, what we can try and do is call a method, and I wonder if we can say that it's oh, what's wrong there? No, that's not what I want. I want to call a method on cursed that is actually inherited from the original. Like it's inherited via the deref trait. So the what we just opened ourselves up to, it's not obvious here, and but if I go to the actual string module, and look at the methods, so we could say that what we should have is an isAsCII method, for example. Oh, it's nightly, so that'll explain why it isn't. What about isAsCII? I'll just assert. I'll just add like another assertion, and just check that the deref tray works. So we're essentially now if we run our tests, we should get 2 OKs, which we do. So well done us. Any questions at this point? You're very welcome to ask them. No is also good. Okay, cool. Now, let's try and go into the actual, there's some more stuff to do. We can implement more traits, but it's very mechanical and relatively boring. We're now going to say that we're going to introduce a couple of restrictions, or at least give ourselves the option. So at the moment we have a vector of U8, which allows us to mute. We could, if we wanted to, enable mutable access. And however, what I want to do now is I want to sort of shrink this restriction down, which is the I want to be able to say that we no longer have write access to the original string because we're going to compress it when it comes into us. If you want to mutate or modify it, you need to kind of do that outside of this type. So we're going to need a very quick refactoring. Instead of doing, we're going to actually ask data to itself provide an asString method. And so we're going to do all the work inside the and this is self.buffer. I need to borrow there. Okay, so we now have a string at the internal level, and so now we can call self.0 as a string. Removal of that. If you're worried about the performance hit in terms of like dispatching between multiple functions, we can ask Rust to inline these calls. The reason why we're going through this sort of slight indirection between the internals representation and the and cursed string is because we really don't want to be able, we're trying to keep our information relatively private. And so if we wanted to, for example, implement what's known as the sealed trait pattern, we could do that on an internal type, which we could expose, which we essentially don't give consumers access to via our public struct. Okay, so now I've got this level of indirection, and I can now change it. So the buffer, I also need a so now I can modify as string as needed. That was kind of the key. So let's introduce a new method. And I need to bring in a compression library. I am open to your suggestions for like which compression library to use. I'd like one that's implemented in pure Rust because it's there's one that hasn't been updated in 8 years, which is great. I'd rather not export ourselves, like I'd rather not I'd rather not bring in something which actually talks to zlib. So I'm curious as to whether or not. Oh. Hey, Jonathan. It's nice to see you. Okay, so what's the compression library? What about Brotley? Which I assume comes out of... I assume it was actually, I know that it's from Google, but presumably it was from Google's Zurich office because Brotley is actually like a Swiss thing. And here we go, cargo add Brotley. We want to be able, so the Brotley compressor, by the way, is quite useful because it's really good at being, I think the big thing is that it's fast. It's objectively not the best compression. However, it is quite good. And I wonder about including some of these other things, like some of these other features, for example, SHA-2 and SIMD. But let's not worry about like the extension features that we could bring in. SIMD should actually increase performance significantly. I'm very keen to do so, but let's ignore that for now. So I've brought in, this cargo add feature has just brought in Brotli version 6.00. And okay, so now we can start with the actual cursing. At the moment, we've just been keeping our data very tame. And so now we're going to start to kind of, how do I put this? We're going to spice things up a little bit. And function is, we're going to start with new. New needs a source of bytes. And yeah, we'll say it's text. And we actually need to guarantee that it's a string slice when we get this in. Otherwise, we're really not going to have a fun time when we try to provide a string later. And so the guarantee in the type system that we have UTF-8 data is really provided by the fact that we have this transparent compression. The one thing that we could consider doing, which I haven't yet, would be to kind of take ownership of the actual underlying buffer. But let's not worry about that for now. Okay, so let's look at the API. We want to be able to here is our, we have some sort of compressor, and we will use the default compression, and then we have like the IO write. Abstraction is not what we want with read. This is going to be a bit annoying for us, because we are not really worried about we actually dealing with kind of raw in-memory stuff. We're not actually reading from files, and so it would be nice to be able to avoid that. So what we need to do here is provide a, I'll show you what this is actually asking for. I think at least. Well, so this is where I need to go slightly off script, or at least I'm not sure if I'm correct. Is kind of what I'm trying to say. So we need a buffer, and that buffer is mutable. We have a vector of U8, and we want with capacity. Let's say we want at least so text.len. Is the number of bytes. So that's convenient. So we need to, at the moment, we have no benefit at all. Because in the worst case, there is no compression. But this will at least guarantee that it will work. Now, here is our compressor. Here's our output buffer, which we actually have here. Buffer size, I think that we could change this. So this is 1000, and like this is 4 kilobytes in hex. Let's give it some more data, and maybe I should just not touch it. I'm notorious for like breaking the wrong thing at the wrong time, and now we need to do something. So we need to actually feed. So here's our parameters, which presumably we can adjust to increase the compression level, and we are writing to this internal buffer. We now need to write. So how do we do that? Oh, I just saw Sid saying hello. So hello, Sid. Welcome. By the way, if you're watching the recording, well done. It's really lovely to see you. Having made it all the way through to like 35 minutes, it's a good hint that you should subscribe. And if you are just following me for the first time, please find a way to like hit the social buttons. Otherwise, you will lose me again. So I try to I try to stream weekly-ish, although in reality it's less frequently than that. But around about this time, as frequently as I can, if I'm not traveling, for example. And we try to implement nice, fun projects. So, welcome, Sid. I hope that you're enjoying the show, and everyone else. I hope that you're also enjoying the show. Okay, right. We now need to learn how to actually write this like data we need to actually do some compression. We haven't sent in the original text. It's still completely unused. So how does one do so? Maybe we should stream a cop. Maybe that's what we should do. Okay. No, the thing that I don't like is that I don't want mutable access to the original input string. But a streaming copy is kind of what I like. I like the sound of that, because we want to avoid the IO traits if we can. I don't really want to manually. What I'm going to do, excuse me for coughing, I'm over, is look in the examples directory and maybe test. Because presumably, so there's their buffer. Write all. But where's the compressor writer standard out? For the parameters. So 11 is the where do they? Oh, and they read in from standard in into the buffer. Okay. I see. So okay. So the idea is that you fill up this buffer. I can't believe I didn't do this. We're going to do this a different way. And then we shrink it. Is the text to owned? In fact, we could actually do it the same way we did before. Bytes. And then collect. But I'll show you a different way. So the bytes to collect method is what we use down here when we used uncompressed data. And so now I'm going to show a different way, which is to owned, which takes a string slice and converts it to a vector. And then we want to say as bytes, or at least as mutable vector. Which is exactly the type that we want. And we probably have an unsafety thing. Why is it unsafe? Safety. This is unsafe because of moving forward with them, but what would you do? If constraint is violated, la 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 la. Okay, so yeah, we need to promise to Rust that we're going to be very good children, or at least we're going to follow the rules. Now, if I have got this correct, which I may not have, we should put a writer, write all, and then buffer. Now, there's currently, one of the things you may notice is that there's no write method or write all. Actually, I'm just going to add to do because I want Rust Analyzer to complain about a different message. Oh no, is it happy? That doesn't make any sense. Cargo build. I expected it would complain about something else that I know is wrong, but I want Rust Analyzer to kind of reveal itself. Okay. So the first error that it was actually hidden by the underscore is that this one here is not imported. And how? So these are just parameters I expect that we'll have an error about this write all method fairly soon. Could not provide compressor. Oh, Goodness gracious. That's not what I expected to see at all. Because I've just pulled the example from the actual... It's not fair when you pull an example out of the... there's a compressor writer. And the parameters, I'm actually going to ignore this kind of weird struct thing, because it seems to be grumpy with me. Oh, it just wants me to borrow it. Okay. So if you can see what I've done there is that, so we finally got to the error message that I thought we would have, but the compressor writer takes this, it's just a different type, so they must have changed the API at version 6 or something, and they haven't updated the README, so shame on them. Now, write all. It's going to complain that there's actually no write method. So let's have a look. Writer, write, oh, no. Oh, so I must have, maybe the editor brought the trait into, yeah, it did. My editor was smart and brought the write trait in. So thanks, you editor. Now I've got there's some other problem to fix. So it was, the error that I thought that I was going to show you was that you needed to bring the trait into local scope before you can actually implement, so call methods on that trait. It was completely erased. It detected the problem, fixed it itself, and then found some other problem. So this other problem is that cannot borrow a buffer as immutable because it is also borrowed as mutable. Now, I wonder if I've got my example wrong. Let me go and also check the comments, because... So the question that Rob has is, is the idea that we're doing in-place compression. There's two, so there are two problems, really. So what we're trying to do is create a type, cursed string, that accepts a string slice as input during its new implement, like during the quarter new, which should actually be from, but it's new today. We have a string slice, and the original implementation, we just copied the bytes to an internal buffer and exported that as a string. So what we're now going to actually add so we didn't mutate anything with the original data. What we're now doing is we're trying to compress the data at rest, and when you come to treat it as a string slice again, it transparently decompresses the data. Is this useful? I don't know, but it shows you that you can actually create types of your own with your own semantics that pretend to be strings under the hood. Hopefully that's relatively clear. I'm getting tangled into knots because Brotli is more complicated, has an annoying API that I don't understand. I probably should have had this all figured out, but I don't. So here's the Brotli code, and we are using this. We've got a writer, but what do we do with the writer is the problem. So this compressor, this is where the typo was. So this is actually a compressor writer. And so I went and looked in the examples for how it works. Here's compressor writer. And we continuously loop over, no. That's fine. We read in some data from standard input, and if it succeeds, so we have some number of bytes that we read in, then we write everything. So yeah, this is where my what I actually want is to say, hi Brotley, here is a reference to the data that I have. Please compress it. And I'm sure for no standard lib, please see the tests. Okay, so the other one would be, and I think we're so close, but I just haven't quite got the pieces in the right place. Okay, so we can either kind of muddle my way through this, and we can do that together. Why is that unhappy? Oh, well, how about I do something different? So here's my text, and I'm going to do something else, which is create. So we need to actually create this buffer in place. So so essentially, text bytes collect. It's confused because there's lots of different ways that I can. I could potentially collect this. Buffer is now asked for it down later on. It says I've got this thing with some parameters, and I ask for mutable access, and so it also wants the variable to be defined as mutable. I'm a little bit... Something is wrong. I shouldn't need... Let's double check. What am I doing? If this was a job interview, I'd be sweating profusely, but luckily I work for myself, and so I just need to embarrass myself in front of friends. So it looks to me as though inside our buffer, we have the data there. And what I'm confused about is that the same field, like, why is it standard out is different than the buffer, which makes sense. So the thing is, like, it is asking, like, where are you writing to? And allow me to just embarrass myself ever so slightly. And I'm going to unwrap because we're doing in-memory operations, we will... Because we're doing in-memory operations, we're not actually working with the file system, so we're not going to bother with... There won't be any I/O. For some reason, the Rust Analyzer is very confused at the moment. That will change. I changed a line while it was updating the buffers, like its buffer, so we buffers all the way around. Now I've created a whole bunch of extra values and compressed things. Let's see if I can do data. I don't like the idea that we are actually essentially duplicating the data and then compressing it. Very strange. So I'm sure this can be cleaned up, but I suppose that is also not the point of today's exercise. What we can now do is kind of go in the opposite direction. We want to be able to read in from our internal data when it's needed as a string. Then we can get it. So it's Brotley. Compressor reader. Oh, it's decompressor, sorry. Oh, is it? No, it's a decompressor writer. Sorry, because again, we do the same thing. If we need like our own temporary buffer, which will be, I might saw the original length. And gosh, I must be boring people now. Oh, except this is the original number of bytes, which is fine because that's what we need for our new our new string slice. So we need to create on the other side, we need to create a, let's call this text, even though it's strictly not text. It's a vector of U8 currently, and it's a vector with capacity self original length. So we have at least sufficient capacity. We know that we'll be able to decompress the text because we've pre-allocated the RAM. Now this accepts a mutable reference to text, and then it also accepts as input a buffer size, which is a parameter for the compression or decompression algorithm. However, what I want to try and just see if I can find out, because it looks a lot nicer. It has this decompress stream copy abstraction, which seems to be a lot simpler to use. I provide my input and my output, and then I hope that it works. Let's see if I can get that to go. Expected a semicolon. Of course you did. Decompress doesn't seem to be in there. I wonder if it's part of it's behind a feature flag that I don't actually have access to yet. It seems stupid that it's in the README, but I'm not able to find it. Or at least I find that extremely frustrating. Like, if it is behind a feature gate, that's okay. I just would like to be told. Where are your feature flags? Let's go and look. Maybe the streaming version. Cargo abruptly. There isn't a external literal pass-through FFI panics security compare. There doesn't seem to be a thing, which is we could look for it in the docs, like in the examples. So here's my example again. But I also think probably it's not worth it. So this one requires standard I/O in? This one has it again. So there's a decompressor with a buffer. Okay. Ugh, goodness gracious. So decompressor goes like this. So oh gosh, this is extremely frustrating. So it's a new method, which I need to bring in the trait IO read and IO write. And now it's telling me that I don't actually need the trait. Trait bound of integer is not satisfied. What? I see. So the read is actually self dot buffer. Oh my goodness, my editor is being very friendly. And apparently vector of U8 doesn't implement. That doesn't make any sense. So the problem was that it's telling me that it doesn't implement as bytes. Sorry, it doesn't implement read. And that's not particularly helpful, correct, at the moment. So what I do to address that is that I know that a byte slice, that is a slice of U8, does implement read. And so I can call the asSlice method on the vector, which returns back the slice of t, which is fine. And now we're happy. Or at least happier. Type allocations. Oh, so currently the vector, this text vector isn't being used. And so the type analyzer doesn't actually know what is going into this text. But I think that I can figure this out. So text write all. And then I want this is confusing me. So here's my reader. Reader needs to read and then put into this temporary buffer. There's standard in. Here's that's temporary. Okay, so I'm going to try and okay, so now text should be filled up with the original source data. And now, if I take a reference to text, this is not going to be very happy because it actually wants to return back because I can't return this text thing is actually a local variable. It will be deallocated at the end of the scope. And so now I have a kind of annoying issue where so I need to return back an owned type. Yeah, so this the error message here is I cannot return a value referencing a local variable text. It returns a this variable text is owned by asString. When asString finishes, suddenly we are not going to be able to play nicely. Like, it'll be deleted, or at least, and so let's try to just try again. So string from. We could actually convert it directly. This is highly. This is quite. This is highly unsafe. So I'd rather not do it in a highly unsafe way. So string from UTF-8. We'll just do it exactly the same way. Text and then unwrap. Aha. Or at least, hopefully, we are more or less okay. And now we have a situation in which string unsafe is working for us. So let's test it. We have a slight issue that our string slices or as string method doesn't quite work as the way that it should. So I'm going to change this to as string, or two. I'm going to call this a toString. I don't know if this is going to be quite what I want. I have an idea of how to fix this by like boxing this, but it's already a pointer type. So let's choose toString. Now as string over here is except we also have the same issue with the fact that it's a reference to a local variable. Someone needs to own this text buffer that is not the callee, I think. Ideally, we pass ownership back, but now we've kind of ruined the semantics of Deref. So maybe my cursing is actually a failure a little bit, but I'm so close. So what I might do is I need to drop off, but what I'm going to do here is, if you've reached this far in the recording and you're extremely frustrated that I haven't finished, check the description. I'm going to update this and have like a fully worked example in my GitHub account. It will be in. I'll update the YouTube. So, and if you're not on if you're watching this somewhere that's not YouTube, then find the video on my YouTube account. I'm actually going to do something a bit wacky, which is to show you a link to the actual YouTube video that's happening right now on a comment about the video. So there we go. So there's a comment, and I can also put up a banner, and I'll edit this one. Boom. So there we go. I'm so close, but we kind of get in this ownership stuff, which is not actually a big problem. I think that we can work around it. However, it will be more of me kind of getting tied into knots. And so my suggestion is that we pause there. And I deeply appreciate your time. My name is Tim Clicks. I'm on the planet to build a better planet. The follow and subscribe buttons are right there. Please do help. Sorry, please click them because it really helps. It helps others find me. It helps. Like, it definitely helps like the self-esteem and the dopamine. Hopefully my cold will recover, and we'll see you. I'll see you online. Take care. Goodbye.